Hello students, welcome back to the new video of power electronics. In this video, we will cover or we will uh, look at a different type of numericals related to your semester syllabus. In the previous two videos, I have gone through with two different topics that were the two different same topics with different applications. But in this video, let's continue with a new topic that's also already included in your syllabus. Here uh, we have questions that is DC series motor with total resistance and inductance of 2 ohm and 2 millihenry respectively is used for rapid transit system is fed through a DC-DC converter. What external inductance should be inserted in series with the armature circuit in order to limit the per unit ripple in armature current 10% for the duty cycle 50%. Assume chopping frequency to be 1 kilohertz. As I told earlier on the beginning of the video that in this uh, in this numerical we will follow a different topic, that is DC-DC converter, and the things which we need to consider first, that is they have asked to consider that the limit the per unit ripple in armature. So we have a DC series motor, total resistance and inductance both are given, and it is used for a rapid transit system, and it is fed through a DC-DC converter. So what is ripple factor? Ripple is in DC-DC converter, the ripple factor can be considered as a measure of the AC component present in the DC output voltage or current. I repeat, in a DC-DC converter, the ripple factor is considered as the measure of the AC component present in the DC output voltage or current. Also, it quantifies how well the converter is able to filter out the AC component from the switching process and provide suppose a smooth DC output, which will record also, because any output consists of noise or any interfaces does not consider as a uh, lossless. It is considered also as a lossy output, which we does not require. And if a lower ripple factor indicates a cleaner DC output with less AC vibration. If we go through with the formula, that is ripple factor as defined as the ratio of the RMS value of AC component to the average or DC value of the output voltage or current. The ripple factor, according to the definition, considered as defined as the ratio of the RMS value of the AC component to the average or DC value of the output voltage or current. Now, how we consider this numerical to be solved out? That is, we have considered the per unit ripple in current is given by I max minus I min by PS by R, and this is indicate for the I max 1 minus e to the power alpha t by t alpha, and I mean 1 minus e to the power minus 1 minus alpha into t by t alpha, and PS by R is considered as a 1 minus e to the power minus t by t alpha. So let t by t alpha is equal to x and alpha is 0.5. We have considered taken, and per unit ripple is 10 by 100 is equal to 0.1, because it has already given in the numerical that in order to limit the per unit ripple in armature current is 10% for duty cycle 50%, and chopping frequency to be 1 kilohertz. So ripple per unit ripple we have considered 10 by 100 0.1 and alpha 0.5 and T by T alpha is equal to X. These are being considered. Now, substitution of this in the above expression, we have just following the step that how does it simplify 0.1, that is X or per unit ripple is equal to, in the previous, let's go to the previous 0.1 is equal to 1 minus e to the power 0.5x and 1 minus e minus 0.5x. So we have put down the value of alpha first and pi 1 minus e to the power minus x. And this is the same value for both the cases, 1 minus e to the power minus 0.5x into 1 minus e to the power minus 0.5x by 1 minus e to the power minus 0.5x into 1 plus e to the power 0.5x. That is the expression we always looking forward, and considering with the very, very importance in this matter, that is whatever the signs we predict and put, that should be always considered. Now, so this is the equal value comes from the equations. So 0.1 is equal to 1 minus y by 1 plus y, where y is equal to the power 0.5 minus 0.5x. There are a couple of assumptions we have taken so far, and y is equal to 0.9 by 1.10. So e to the power minus 0.5x. And as we consider e to the power minus 0.5x to the left hand side, it's become positive 0.5x, e to the power 0.5x only is equal to so 1 triple or 4 number of 2 or 1.2, whatever the value comes here, we have put it down. Now x we have considered t by t alpha is equal to x, so 0.4134. Somehow we able to manage or we able to calculate the value of x. Next, t alpha is equal to t by alpha value. We have put at the alpha value. T is equal to 1 we consider, but 0.0134 f, that is the frequency we have considered, but f we all know 1000 hertz, or as I said 1 kilohertz. So we have converted 1 kilohertz to the 1000 hertz. Then put the value t alpha is equal to 1 minus 0.40134 into 1000 as a frequency, and L inductance is equal to RT alpha. That is the value we have chosen, or we have put it down according to the solutions we have got so far from the above equations. So this is the amount of inductance millihenry that is considered for a DC series motor, which is used for the rapid transit system. So therefore, as in the question, they have asked that what external inductance should be inserted in series with the armature circuit. So therefore, the external inductance that should be inserted for keeping the per unit ripple within limit, that is 4.9 minus 4.983 minus 2, that is 2.983. So this is the external inductance, amount of inductance we required to order to limit the ripple, of the circuit. And so when we conclude, this numerical is little bit harder than the previous two slides or previous to the videos, where in the last two videos we have just implemented the basic applications, and now we have just touched the basic advancement of the power electronics concept in the numerical type. So when such kind of issues will be considered, we will follow the basics concept of the numerical formulas related to the ripple factor, converter, or thyristor, whatever the topic we have given to execute. Thank you for watching the video.